Okay, OPM 2000 as my camera shakes. It's like shaky cam in the movies. Yeah, it's a horror movie and it's on shaky cam. But seriously. Um, so this is week 9. A couple things first. Make sure you keep up in Canvas with your discussions and assignments. And yes, my dog is going nuts right now. Apologize him in the background going bananas. He's waiting for his dinner, which he will be getting shortly. Um, This week, towards the end of the week, I will be putting the midterm grades into the grade book, and so you'll be able to see those. Let's go ahead and jump into this real quick. This week, you're diving into um, Six Sigma. You're diving into quality management systems. Six Sigma is one that is used. It was originated at Motorola. Um, Companies like Motorola and Texas Instruments were among some of the first that actually employed it. Um, it's indicated by a sigma, which is, it looks like a zero with a little bill coming off the top of it, or an O with a little squiggly at the top. That is a Greek letter, the Greek letter sigma. It's the lowercase sigma. A higher case sigma looks like the weird um, E, which we use in mathematics for sum. That's what that means. But it is a sigma. But for Six Sigma, we use a lowercase because the larger case is already taken by meaning sums. Um, We look at Six Sigma in parts per million, or I should say defects per million. So your Sigma quality level is equal to 3.4 defects per million opportunities. And so that would be worded as 3.4 DPMO in Six Sigma. I do have my black belt certification in Six Sigma. Um, I don't have my Agile. I'm familiar with Agile, but my certification is in Six Sigma. Um, so what does that mean? Are we wanting to be at a three sigma? Well, a lot of companies, three sigma is actually pretty good. Um, you look at one sigma is virtually impossible. Pardon me. Six. It's a level 6. I always get it backwards. Level 1 sigma is not good. That's horrible. That means you got lots of defects per million opportunities. At the level 6 or 6 sigma, that means quality means that for any given product or process quality measurement, there will be 3.4 defects produced per 1 billion opportunities. That is substantially astronomically phenomenal. And most companies that use Six Sigma, they make being Six Sigma its goal, but they know they're not going to really achieve that level. That's virtually impossible in most cases. So they're content to be at a 5 Sigma, even though they're still continually working. Remember, process improvement, it's a continuous process. They're continually trying to get to that Six Sigma in the hopes that one day they will attain it. But even a 5 Sigma is substantially better than being at a 1 Sigma. It means that in your production line, you're producing fewer products that have to be rejected in the quality assurance phase or that are going to be returned from the customers because of defects. And so that ultimately is what you're trying to do. You're maximizing what you're spending. We spend time, we spend money. Those are resources. Um, we make the product. We want the customer to buy it and be happy with the purchase they made. If they have to return it because it's defective, we are going to have to pay for that customer to get a new product. And we don't want to do that. That means that now instead of them getting this product and the amount that we paid to create it, we already got back in our profits. Now we got to send it to them again, but we're not getting any more profits back. And so it's important that we reduce our defects. Now, Six Sigma, it is possible to use Six Sigma in other industries other than just manufacturing. It's really suited for manufacturing, but you can use it in the healthcare sector. You can use it in the hospitality sector, restaurants. It is possible to use Six Sigma across the board in virtually every sector. Now, you got to consider what set of processes for Six Sigma are you going to use? And Six Sigma The common process that's used, the normal approach, is the DMAIC or DMAC, and that stands for define, measure, analyze, improve, and control. Now, let's take, for instance, DMAVD, which stands for define, measure, analyze, design, and verify. I would use DMADV if we are involved in an innovative process. We are designing something new or we're changing a product. If we're dealing with an existing product, I'm going to stick with the DMAIC because it's suited to what we need. Now, in the process of going through these steps, you collect all your data. You're defining what the problem is. You're using metrology, not meteorology. Those are the guys that say it's raining or not. But metrology is the science of measurement. You use metrology to make your measurements. Okay. That's how we're going to verify if we're being effective. We know we're making defects if our meteorological readings, our measurements, show that instead of being 4 microns, it is 3 microns. We have a problem, or it's 6 microns. We got to know what the tolerance is. Can we make an error and be within tolerance? So we're collecting data. We're going to then analyze that data using any number of calculus equations. I say yes, calculus. It is calculus that's done when you're doing process control, quality control, process management. Things like ANOVA, MANOVA. These are different tests that are done. ANOVA is an analysis of variance. You might do central tendency equations. You might do t-tests, okay, f-tests. These are different tests that are done in this quantitative approach, this analytical approach to data. Now, as a researcher, I don't deal with that type of data. I deal with the human data, and that's subjective data. I mean, you're able to work with it, but you always got to bear in mind that it's subjective. And so your area of tolerance is a little bit different there. Also, we don't typically use equations, although I'm qualified to do quantitative analysis, that's statistical analysis. It's not my forte. So this week, you're going to read about Six Sigma. You're going to do your homework. You're going to do your discussions. There's one more thing, one more concept I want to bring to your attention. Let me save that file. I'll be posting that here just shortly. And that is the PDCA cycle. Plan, do, check, act. The PDCA, I always get those letters mixed up there. Dyslexia, it's wonderful. That is something we're going to be using for new improvement projects. We're going to use it to define a repetitive process. We use it when planning to collect data and to identify the cause of a problem. If we want to implement change, or if we want to work to improve a process, it's a good way to approach things, but it's not as detailed as the DMAIC that we find in Six Sigma. And so we could use the PDCA without using Six Sigma, but it might just be what we use in defining what the problem is. And then we switch to Six Sigma and the DMAIC, the DMAC, and then we start the actual process of analyzing what's happening here. And so your PDCA is going to be a little bit limited. It's not as mathematically intensive. So it's suited for a number of things, but you can only go so far with it. I wanted to kind of introduce that to you before you jumped in. I will be posting 2 sets of lecture slides that I use for this part of the course when I teach it in person. I need to pull up this week in Canvas. Where's that at? There we go. You have a discussion. Your initial post is due Wednesday, and you need to reply to at least 2 of your classmates, and that's due by Sunday. And then you have a capstone milestone. You're going to be working on an A3 report. Now, simply put, the A3 report, it's named as an A3 report simply for one reason, and that is the size of the paper it's typically done on. It's a larger piece of paper. It's the A3 size, and that's why that report is called it. Now, there is going to be, and let me pull that up here. There's a template in the instructions for that assignment. It is partway through the page, about, I guess, 2/3 through the introduction, through the prompt. And it says for a template to do A3, see enter Miami A3, use that template. Okay, that's the template that you need to use to do your A3. As you're going to find out, an A3 is very specific into the sections that it contains, but there is area for creativity. In those sections, you can include diagrams or pictures or relevant data, anything to try to get across what it is that that section of your A3 report is dealing with. You can be creative here. Okay. This is one place in operations where creativity, it's not going to be limited here in innovation. Those are two areas that you can be creative. So, but you want to follow that format, especially just starting off doing your A3s. Otherwise, you're not going to understand the sections. And the sections of an A3 report really mirror the PDCA that we just talked about. So I hope that you have a great week. I look forward to seeing your discussions, and you, hopefully you're staying dry out there. It's a wet day for sure. You have a good day and a good week.